Good afternoon, everybody. Welcome back to our class. So, for this week, we'll learn about acid and base behavior in aquatic systems. This topic is something it's not new for you. You have learned about acid and base before, about pH and so on. And for this topic, you will learn on how to apply acid and base in aquatic environment system. So what you're going to learn for in this topic, we'll focus on redox reaction. I hope you still remember. Maybe some of you have learned about redox. So redox is reduction and oxidation reaction. So usually it occurs simultaneously. So that's why we call it redox. And acid-base reactions, we focus on carbon and sulfur for this topic, but it is not limited to carbon and sulfur only. So we can go beyond that one. We can go to nitrogen, phosphorus, and so on. But for this topic, we must focus on carbon and sulfur. All right, so we start with definition, very important one. Look back on redox reaction. So redox reaction is chemical reaction that involve transfer of electrons between two species. Okay, species here is about the same chemical component, but they will have a different charge. For example, zinc. Zinc can be in solid phase, and it also can be in dissolved or soluble phase, which is not stable phase. So the solid one is only zinc. And so dissolved or not stable one, it may be zinc 2 or zinc 3, zinc what are the isotopes that they have. Okay, redox reactions are common and vital to some of the basic functions of life, such as photosynthesis reaction, respiration, combustion, and corrosion, and also rusting. So you need to know that the molecule that accepts electrons, okay, receive electron, we call it oxidizing agent. That the molecule that give electron is reducing agent. Of course, when you give something, you will have reduce. So in this term is reducing electron. Okay, this is example in the thermite reaction where iron oxide react with aluminium, and then iron oxide will lose oxygen atoms, and they will donate oxygen atom to aluminium, and then we get aluminium oxide. And also molten iron, because iron, when it's not react with oxygen, so it's in liquid form. So that's why in molten iron is pure form of iron. Okay, so that is how they can get back iron, and they manufacture so doing another thing with iron. So you buy using the molten iron. And how to identify the oxidized and reduced element? Look at that example here. So zinc, when it react with additional hydrogen ion, so it get the electron from hydrogen to zinc. So zinc has two electrons now, and hydrogen become gas. So what's mean here, oxidation state for hydrogen changes from 1, because in the beginning it has 1 um, electron, to 0. And the oxidation state of zinc, it changes from 0 to 2. So that means here zinc is oxidized. So remember, just now we said that when you accept electron, is we call oxidizing agent. Okay. So zinc is oxidized and and act as a reducing agent. Why reduce? Because actually zinc, actually they have everything, and then because hydrogen ion has lack of electron, so it donates electrons to hydrogen. So that's why we call reducing agent. So the reducing agent, uh, they the process that they undergo is oxidation, and hydrogen ion is reduced. Means they have less ion before, and then it accept more ions from more electron from zinc. So we call it oxidizing agent, and it's reduced. Okay, this table show um, more examples of redox reactions in natural waters. You can see the reaction of oxygen with hydrogen. So because that in water, remember water we have H2O, and that means we have oxygen, we have hydrogen. Not only that, we also have carbon, okay, from the carbon dioxide. And what else we have? We have sulfur, iron, and many more that we call seawater matrix. Okay, so these elements have a wide range of oxidation states, and their speciation and interactions affect all other physical, chemical, and biological processes occurring in water. Okay, before we move further on application in the water system, let's recap from the last learning unit. So last week, we learned about auto-ionization of water. So water is actually can ionize themselves to become hydrogen ion and hydroxide ion. With the Kw, the value is 1 time 10 minus 14, and the pH for the natural water or fresh water is 7. However, the concentration of hydrogen ion and hydroxide ion is also affected by major components in seawater. They have a lot of other seawater matrices that may influence the pH of seawater. Therefore, the value of Kw in seawater is a little bit different, a little bit adjusted to less than natural water. Then the Kw is about 13.19. Okay, no 14. Okay, so the reducing in the pKw value is actually related to reaction of hydrogen ion with carbon and sulfur. So that's the reason why we want to focus on the carbon and sulfur in seawater for this topic. Now have a look on this one. So first here is about photochemical redox reaction. So dissolve carbon dioxide and carbonate speciation in water. It's actually starting before it enters the water. So carbon dioxide is available in our atmosphere. Okay, so from atmosphere, from our surrounding, enter the water. Let's say it's entered during the daytime, during the daylight. So they have sunlight here. So sunlight has their responsibility there. So it will the reaction it causes photochemical reaction, redox reaction. So carbon dioxide enter the water initiated by oxygen free radicals. So it will produce by interaction oxygen and sunlight. Stronger oxidizing agents, stronger than oxygen, they're unstable, but however it occur very low concentration. Okay, you see here, redox reaction occurred simultaneously. So what's mean here? Oxidation reaction occur in the same time reduction reaction occur. So when the carbon dioxide react with water and react with oxygen in water, so it can form formaldehyde, or we call it carbon organic carbon. So ratio, so this is not stable, so they will convert back to carbon dioxide and water, and then this ratio will continue until finish. So remember, when carbon dioxide react with water, your oxygen, so it becomes formaldehyde. So that is the photosynthesis reaction. In surface water, we have a lot of phytoplankton that will undergo the photosynthesis reaction during daytime. And then the second reaction is hydrogen sulfide. So hydrogen sulfide usually can be found in the area, it means in the seawater that close to either the combustion from the land, because combustion from the land, for example, forest fire combustion, a certain time in the year, so there is a forest combustion due to the plantation that want to what we call that one, they want to reduce the the waste. So by burn it, however, it release hydrogen sulfide into the atmosphere, where uh, with the help of wind blowing, bring hydrogen sulfide into the sea water, and then the reaction occurred. When it react with hydrogen sulfide, it will give sulfate and also water in water. Hydrogen sulfide also can be found at the sea floor. So maybe you wonder how hydrogen sulfide can be at the surface water. So you must think about the wave. So sea has waves, strong waves, strong radiation. Means vertical water mixing. Okay, so by wave, by currents, and also other uh, uh, what call it, other reaction or other processes that bring the hydrogen sulfide from the sea floor into the surface water. So another place that has hydrogen sulfide abundantly in hydrothermal vent. So in the location, if it is at the sea waters near to hydrothermal vent, so we have more hydrogen sulfide and more sulfate and so on in the seawater. Okay, so what does that mean? So it will disturb the condition. Nobody said it will control, it will influence the condition of seawater at that particular area. Remember, hydrogen sulfide is a green gas. It's a green gas, so it's not safe. It's also toxic to human. The next one is methane. So methane also available in water. Uh, Also, that is something. Oh, sorry, hydrogen sulfide and methane also you can be found it. Also, you can find it at the oil and gas platform in the middle of the sea. So because it will release a lot of that um, gas into the surface water. That is for oxidation. If you see that the ratio of oxidation is about the same. When formaldehyde they convert to carbon dioxide and water. So in the same time, when the water, the carbon dioxide react with water with the presence of formaldehyde, it will give oxygen and also water and carbon dioxide back here. So same with this one, sulfate, because it is not in the steady state, it's not stable, so it can convert back to hydrogen sulfide and carbon dioxide. And here also carbon dioxide, remember carbon dioxide is not stable, so it can combine back to methane and also carbon dioxide. Carbon dioxide can also react with water and form carbonic acid. Carbonic acid, okay, you can see here. So when carbon dioxide enter the water, it can form carbonic acid. Carbonic acid is not stable, so it still can be um, ionized into other forms. So carbonic acid, it can release hydrogen ion and also carbonate ion here, carbonic acid. And remember this also not stable, so still have hydrogen ion here to release. So from the carbonic acid, so release the ion, the hydrogen ion from here and the carbonate ion. So in this state, both are not stable, so they will fight between each other to get this one can react with oxygen, the free radical oxygen here, or maybe can react with carbon dioxide to form back the carbonate ion here, because this is two ways reaction. Okay, and carbonate can react with calcium that are abundant in seawater to form calcium carbonate. Okay, I want to show that one because we need to eliminate that. Alright, so calcium carbonate exists in two forms, aragonite and calcite. Okay, so both are different. So aragonite and calcite, some of it are important in developing coral reef, developing coral, the skeleton of coral reef, and another one is responsible for the developing the shell of the um, mussels. Okay, the shiny shell one, the part. Okay, so the okay, which one is which? Okay, so please check. That is your task. I want to give you to check about find information, more information on aragonite and calcite. Okay, so the reaction of calcium carbonate, okay, remember because this is not stable, so the reaction can be both sides. So calcium carbonate, even though they are in solid form, it can turn back into calcium ion and carbonate ion. So calcium ion is constant. So that means it's really depending on the carbonate ion. Alright, so this is the activity for gamification. Perhaps it's not activity 3, but it's a gamification activity. The next one, there are two questions that you need to do. The first question is there. In your opinion, what are the importance of calcite and aragonite in our aquatic environment? I've explained just now, but I did not explain which one is for aragonite, which one is for calcite. Please find information, detailed information of that one. And number 2, let's say we have more carbon dioxide available in the atmosphere, what damage it will cause to aquatic environment. I have show you this one. You see that the carbon dioxide, the first ration is from the environment. Let's say we have more carbon dioxide here, more input of carbon dioxide from our environment. And then you give your opinion based on your reading what damage it will cause to aquatic environment. Okay, so that means here I want you to talk about the negative impact of more carbon dioxide released into our seawater. Okay, so clear about this one? So this part hasn't included in your lecture note that I give you on edit. So please take this part, you can jot down and later you can do this activity and submit on edit. Okay. Next, we proceed for alkalinity. So this is another term. The import is really the interrelated. For when we are talking about carbonate or carbon cycle or acid base in aquatic environment, alkalinity is part of it. We cannot ignore it. Okay. So what is alkalinity? What is alkalinity? So alkalinity represents the ability of water to resist acidification. Why? If there is alkalinity is like buffer, okay, so if there is the alkalinity is not there, so that means the pH of our seawater can easily change over time, especially when something pollutants or contaminants, or maybe when um, the daily changing, so means day to daytime to nighttime something, so reaction of the photosynthesis and what else, the respiration and so on, so it will change the pH so easily. So we don't want that thing to happen because certain aquatic organisms are very sensitive to the pH changing. Okay, so that's why it's very important to know how it happened. You know that the seawater pH is very hard to change, even though you have done like maybe a lot of acid, or maybe our seawater receive a heavy rainfall, so the pH is not easily can be changed, okay, due to the alkalinity, thanks to alkalinity. All right, so what is alkalinity? It's actually based on what calculation, okay? So you can see that if you want to find the concentration of alkalinity, you need to sum up or add up all the ion, especially the negative ion, such as carbonic acid, carbonate, hydroxide, and also you can see this one, all the negative ion that related to carbon. You add up of this one, and then you need to minus the concentration of hydrogen ion and other bases. Okay. However, you the value for hydroxide ion and also the hydrogen ion other bases are very small that we can ignore in calculation. So usually they will use only they will look on these two important part when you want to calculate alkalinity that have carbon there. Okay, so the common unit for alkalinity is usually equivalent over liter, or EQ over liter, or milli equivalent over liter, or micro equivalent over liter, and also sometimes they say milligram per liter as calcium carbonate. Okay, so that's why last week I asked you to do a mind map about how do you want to convert from one unit to another. Because of this one, you cannot convert, you cannot just say equivalent per liter is equal to milligram per liter. You must know how to convert to get the same unit as milligram per liter here. However, alkalinity is different from basicity. Basicity is depending on pH value. Okay, so it's easy to change. So what's mean here? High pH value does not mean high alkalinity. And changing alkalinity does not have to cause pH change. Okay? So if you look at the equation down there, that is how it show you how you can convert from one unit to another. Okay, so please have a look carefully there. So between mole per liter, how do you convert it to equivalent per liter? So it's time with valence and ppm part per million of calcium carbonate. So you need to time 50,000. So that is the formula. So you need to know step by step how to convert it. Alright, this is the example question that you can do. So the question is, the wastewater with pH 7 has calcium ions about 50 milligram per liter. So 50 milligram per liter for calcium ion. And also that wastewater contained bicarbonate ions 130 milligram per liter and 100 milligram per liter carbonate ion, bicarbonate HCO3, okay, and carbonate CO3, CO3, okay. Then the question asks you to calculate total alkalinity value. How are you going to do this? Okay, so you need to check. I will provide you the how to solve this one in another. I put it in the PDF file later on Elite. Please check it. So actually, you need to know the concentration and equivalent weight. So equivalent weight is also known as molar mass or formula weight or something. So that have value has unit gram per mole, and then you can calculate alkalinity as calcium carbonate. I will show you how to solve this one in the PDF file later. Please check on Elite regularly. Okay. Alright, this one, another example, but this question asks you to estimate the carbon dioxide concentration in your catfish pond. Okay, how you can get carbon dioxide concentration if the pH of the pond is 7.2 and the temperature is 25 degrees Celsius and the total alkalinity is 103 milligram per liter. So you see here, this question gives you the total alkalinity value, but asks you to estimate the carbon dioxide concentration. Okay, so actually here, oh sorry, you look down of table 2 there. So actually they has highlighted, look at the one that I circled it. Total alkalinity, how to get it. So the factor given in this table, you need to multiply by the total alkalinity value given to get the carbon dioxide value. Okay, so it also give information there for practical purposes. Carbon dioxide concentrations are negligible above pH 8.8, 8.4, sorry. Alright, so that's why the table is only up to pH 8.4. Now look at the question back. How do you want to find the factor for your question? Okay, it gives you the pH value 7.2. Okay, you look at 7.2 here. So 7.2, and they say that you need to multiply with the alkalinity. So you have the total alkalinity value here. So that's mean, okay, you give temperature just now, right? 25 degrees Celsius. 25 degrees Celsius at 7.2 is here. So the factor is 0.124. So you need to take this factor 0.124, multiply with 103, and then you will get the carbon dioxide value. So that is estimation. So you can calculate yourself what are the value. What are the value that you will get? Let's do it together. Okay, so the value is, you get it? It's very easy. So look at 25 degrees Celsius temperature and at pH 7.2 to 0.124, you need to multiply with the total alkalinity value, that is 103. So you will get 12.772 milligram per liter of carbon dioxide. So that is the value of carbon dioxide for that at pH 7.2 at temperature 25 degrees Celsius. Uh, Total alkalinity, when the total alkalinity is around 200 milligram per liter, so this is a good buffering capacity of water source. It will help to reduce the pH changing. So pH changing can be very fast if something or some maybe acid or base release in the water system. So it will not good for other aquatic organisms such as fish, prawns, something, especially to those very sensitive to the pH changing. Okay, so alkalinity in fresh water is around 5 milligram per liter. Usually that one, because soft water, to up to 500 milligram per liter. So we call it hot water. You can see this one. Even in fresh water, so total alkalinity at certain area can be more than total alkalinity in the in seawater. So it depends on the water at the fresh water at the certain location. So in Malaysia, usually our fresh water is, we can consider it as soft water. But in certain area in the world, such as in the United Kingdom, they have a problem with lime scale. So because they have a high alkalinity value in their fresh water, and eventually it also will disrupt their tap water. I will show you how bad the impact when we have very high alkalinity in the fresh water. we cannot eliminate all, but it's not very nice to drink water that have high lime scale. So what problem it causes, especially to our tap. Okay, so seawater is less than 120 milligram per liter, and seldom we can see pH problems in natural seawater. Okay, so this picture shows you some hot water problems. You can see that lime scales damage the dishwasher interior here. Also, lime scale build up on heating elements. What happened? Remember, when the heat water, so it become some of water become vapor, and then it will lift up, so easily to build up lime scale at the heating element, such as because in the cold countries, so they have winter, so very cold, so they have heating element in their tap water. So this is in the pipe. You can see that lime scale has almost blocked this pipe. This is lime scale. Okay, the white one here. So they will have a water disruption, maybe water flow become very slow because of this thing. So they need to either clean it frequently or change the pipes. So in shower head, this is a common problem. You can see the white stain on the shower head here, and also on the tap. This is the white one. So this is a lime scale on the tap, and other hot water cylinders. All right, so that is some impact to environment, to us. Alkalinity is important for fish and aquatic life, as I said, and because it protects against the rapid pH changes. Aquatic life can function the best in the pH range of 6 to 9. You can see this one, that is the pH of fresh water and seawater. What is pH for seawater? pH for seawater is around 8, 8.1, or just around that one. Okay. If it's close to coastal area, so the pH will be slightly lower, but not less than 7. It must be more than the freshwater pH. So high alkalinity level in surface water will buffer acid rain. So that is another good impact of alkalinity, because it will buffer acid rain. I told you earlier that rain, especially in our country, we receive rain almost the whole year. Like in Sarawak, we receive rain almost every day now. During the evening, so we see rain is raining outside the building now. So acid rain has a pH less than 6. Sometimes it can go low until pH 3. So it can give many negative impact to our building, to our environment, and so on, if there is no alkalinity to buffer the pH change. Okay, especially at the surface water. Why is very important at surface water? Surface water is like many activity happen there. Photosynthesis by the phytoplankton. The phytoplankton is a tiny plant in the water. So it produces a producer to the aquatic environment. So it's the food, main food to fish and other aquatic environment. So if the pH ruined, it can become easily changed. So it will affect the photosynthesis reaction. What it will affect? The oxygen. So the oxygen from the atmosphere into the water also will affect, and fish may die. Then we can get a lot of problems because of that one. Okay, just now we talk about acid rain. Acid rain caused by the sulfur redox reactions in water. So this is the thing. I hope you still remember. Just now I said hydrogen sulfide or sulfur is not natural in the pristine water. So usually it high if the seawater is close to the industry that near to coastal area that have a very active industry releasing smoke. Smoke sometimes contains hydrogen sulfide from the car, from the uh, combustion, fire forest combustion from the land. They release sulfur into the atmosphere and into the water, and then it flows to the oil and gas platform. So releasing hydrogen sulfide from the sea floor into the surface water, and what else from the thermal, so hydrothermal vents also have a lot of hydrogen sulfide or sulfide. Okay. So the forms of sulfur in water depends on the pH and the redox potential of the water. So sulfate ion when react with hydrogen ion. So remember this one is free radical ions are available abundantly in seawater, so they can react between them and with additional of more electron. So sulfate ion can change to sulfur. The sulfur, even though it's solid, can react back because it is not stable. So it can react back with hydrogen ion with additional of electron and form hydrogen sulfide. Hydrogen sulfide, it can release hydrogen ion and hydrogen sulfur. Hydrogen sulfide. Okay. Okay. So acid rain. In the pure water, the pH is 7. But atmospheric carbon dioxide dissolves into rainwater, causing pH to reduce a bit. It means it will be less than 7. However, it cannot be less than 5. Due to acid, due to other reaction, especially with hydrogen sulfide, the rain pH can be lower than 5. So that's why we call acid rain. When the pH is lower than 5, it's not good for our environment, even for Earth. Imagine a splash of acid that have pH 3 drop on your skin. What will happen? Because pH, the what we call that one? Sifat dia is corrosive. Okay, so you know that carbon dioxide is not able to reduce the pH below than 5. So there must be another thing that responsible for that one. So formation of acid rain is usually the culprit is sulfur dioxide with the help, okay, so dia ada kawan dia with nitrogen oxide. So these two um, components or chemical components mostly emitted from human activities. Okay, from the combustion, from the industries and so on. Okay, now let's have a look on how it actually turned, because when you see here it say that only sulfur dioxide, so that is not acid. How come it can give a pH value lower than 5.6? All right, sulfur dioxide react in oxygen in atmosphere, okay, because it's not in the atmosphere, react with oxygen in atmosphere, and then it gives to be sulfuric SO3. Okay, and when it enter into water, so the first reaction here occurred on the atmosphere, and when enter into water, immediately the reaction happen, and what will give you do? It give you sulfuric acid. So that sulfuric acid is responsible to change the pH of the rain. Rain is fresh water. Okay, so another one, because just now I said that it's not only sulfur responsible for sulfur. Nitrogen or nitrate is also major component of acid rain. When in combination of sulfur dioxide with nitrogen oxide, so will be the pH may be lower than 5. So again, nitrogen oxide react with oxygen in atmosphere to give nitrate, and then we enter the water. See, in water also have free radical oxygen, and then we form nitric acid. So these are two components as that cause acid rain, sulfuric acid and nitric acid. Okay. All right. So this is another game, the game activity for you. You need to answer this one and post your answer on Elite. So the question are, number one, in your opinion, what problem it may cause to our environment due to the acid rain, and suggest ways to protect it. Alright, so here I said environment. It's not necessarily must be seawater, must be sea. It can be anything. Our environment. You can think about our building, our house, our car. That's also environment, because it's from acid rain. It can cause lot of damage. And I want you to give your opinion. What kind of problem it cause to our environment due to the acid rain? Not just say that it will damage our car. No, you need to explain. Give a further explanation on for your answer, okay? And also, you need to suggest how to protect it from happen, how to protect our environment from acid rain. Second one, um, we are lucky this year we don't have haze, which before this occur almost every year. Haze occurred during August and September usually. And I want you to think, not only think, you need to find information based on your reading on internet, or maybe if you have a reference book, you can access a reference book, because now we have a lot of e-book for references. You can find about haze. So the second question here is, can haze cause the acid rain? If your answer is yes, you need to explain how. If your answer is no, also you need to explain why. Okay, so that is two questions. So for this lecture, you have two gamification activities, game activity 3 and activity 4 here. So both activities, you need to submit your answer on ELIP. Okay, I will give the please check on the due date for both activities. All right, so that's it for our lecture for this learning unit 3. If you have any question, you can